Okay, welcome. This is Unit 11, Day 1, Math Analysis. So you can see the OBJs for the day. We're going to use math induction. Now, we're not going to do the whole lesson. As you can see, this inductive reasoning and deductive reasoning, we're just going to cross those out because you did those in geometry. Unfortunately, we don't have time to do everything with this new material that we need to get to, so we're just going to cross those out. So today we're going to concentrate on math induction. So there you can see your objective. So here is the principle of math induction. I'll give you a moment to read that. All right, so the bottom line is for math induction, in order to prove this, we have to show that it works for the first term, p sub 1, and we need to show that it works for the next term, p sub k plus 1. Okay, so first term and the next term in the sequence. Okay, all right, so here's some what we call preliminary examples. Make sure that's lined up. Okay, so we want to find p sub k plus 1. So here's our p sub k. So we're just going to write p sub k plus 1. So what we're going to do is replace each k with k plus 1. So just be careful here with this k. We're going to put it in parentheses. And then this k, put that in parentheses. So I replaced each k with k plus 1. Now let's clean it up. This is just going to stay put right there. But here we have k plus 1 plus 1, so that turns out to be k plus 2 inside the parentheses. Okay? And that's your answer. All right, let's try another one. All right, so again, every time you see a k, we're going to replace that with k plus 1. All right, so replace every single k with k plus 1. So if we clean this up, so we got to be careful here. This k plus 1 minus 1, that's just going to turn out to be k. So times the 4 out front, and we end up with 4k minus 3, all that in there. Okay, so again, we got the k plus 1 minus 1 all in parentheses, so the 1 minus 1 is 0. So all of this turns out to be a k times the 4 minus the 3. All right, now here it's a little more challenging. We got to distribute that 4. So that will give us 4k plus 4, and we still have that minus 3. So we'll clean that up in the next step. So I'm just going to put regular parentheses around this guy here. And then the 4 minus 3 is 1. Okay, and there's your answer. Okay. Part C. Again, we're just replacing each k with k plus 1. Okay. So here we're going to have the k plus 1 plus 3. That turns out to be k plus 4. I no longer need that in parentheses. If you have the parentheses, no harm. And we don't need to actually multiply all this out. So just leave it as it is. And there's your answer. Okay. Okay, so again, we're just replacing the k with k plus 1. All right, last one like this. So we're going to replace the k with k plus 1. All right, so replace every single k with k plus 1. Now when we clean this up, make sure that k plus 1 is your exponent. Distribute the 2. And that will give you 2k plus 3. Okay, so these are the easier examples. Just replacing each k with k plus 1, and then just take your time when doing it. Now, here is the real math induction. This is where it gets a little more challenging. Okay, so here's our example 2. So we want to prove this using math induction. So there's 2 things we need to do. We need to make sure it works for the first term, and we need to make sure it works for the next term. Okay, so step 1, we need to make sure it works for the first term. So that first term, Rn is going to be 1. So the sum of one term. Well, the first term is 5. Okay, so now we're going to go here to the end, and I'm going to replace that n with 1 since we're concentrating on the first term. So replace each n with 1. Okay, so 1 times 1 plus 4. Well, if we clean this up, 1 plus 4 is 5, times the 1 gives us 5, so it checks. So this works for the first term. Okay? Now, step 2, this is the hard step. We need to make sure it works for the next term. So we're going to do some preliminary work here to help us out to get what we call a target. So I'm going to replace this n with k, and come down here at the end and replace each of those n's with k. It's just something we do with math induction. Don't think too much into it. So we have s sub k is equal to k times k plus 4. Now, the next term, we're going to replace the k with k plus 1 because that will give us the very next term. So replace each k with k plus 1. All right, and if we clean this up, that's going to just stay put, k plus 1. Now this k plus 1 plus 4 will give us k plus 5. Okay, so this is our target. That's what we need to somehow get. Okay, so it's always good to do that ahead of time. That way we can know if we get there when we're doing our proof. Okay, so now go back up here, replace that n with k plus 1. So we're going to put in our sequence here. And I'm going to replace that n with k. Now, like I said, we want to show that it works for the next term. So we're going to add the next term. Well, the next term is going to be 3 plus 2 times k plus 1. If we were to continue this, the next term would be k plus 2, and the next term would be k plus 3, and so on. But we just want that very next term. All right. So we need to somehow prove that all of this is equal to our target. So this was the original sequence, right? So that's our s sub k. We're just adding the next term. Okay, that's this part. Now, if I clean all this up, hopefully you can see this. If I distribute the 2, that will give us 2k plus 2. Well, the 2k plus 2 plus the 3 will give us 2k plus 5. Okay? So the original sequence plus the next term. So I replace the original sequence with s sub k. This is our next term. When we clean that up, we get 2k plus 5. Now remember, our goal is to somehow turn all of this into our target. That's our target. That's what we want to get to. Now this S sub k, if we come back up here, that's going to be k times k plus 4. Okay, now again, remember, all of this should somehow end up to be our target. Okay, so we're just going to distribute the k. Clean that up. Okay, now again, look at your target. We're almost there. If we factor this trinomial, we end up with k plus 1 times k plus 5. There's your target. That's how you know that we did it correctly. Now, math induction is not easy. It is not easy. So remember the 2 steps. We have to show that it works for the very first term. Okay, here's our first term. And then we have to show that it works for the next term. Okay, here's our next term. Okay, so that's why we do this preliminary work to get our targets. That way we know what we're trying to get to. Okay? Now, honestly, this problem right here is actually pretty easy. This one right here is very challenging. So this is about as hard as it gets. All right, so buckle up. Okay, so let's do our steps. Step 1. We need to show that it works for the very first term. So the sum of one term. Our first term is 1 squared, as you can see. If we go here to the end, replace each of those n's with 1. Okay, now if we do all this, well, we know 1 squared is 1, right? If we do all this, we should get 1. Okay, that's your first term. All right, so 2 times 1 is 2, plus the 1 is 3, so all this is 3. 1 plus 1 is 2, so now we have 1 times 2 times 3, which is 6. 6 divided by 6 is 1. It checks. Okay, so we have to show that. That's step 1. We have to show that it works for the very first term. Now, step 2, this is where we do some preliminary work. Okay, so we're going to replace the n with k. So now instead of s sub n, we have s sub k. Come here and replace each of these n's with k. Okay. Again, this is all preliminary work to help us out. So now we're going to replace that k with k plus 1. So every k you see here, replace it with k plus 1. So that replaces this k. So here we have k plus 1 plus 1. And here we have 2 times k plus 1 plus 1. Now we're going to clean all this up, and remember, this is our target. All right, so if we clean all this up, we have k plus 1. This k plus 1 plus 1 is going to be k plus 2. Now here, when we distribute the 2, it's going to be 2k plus 2 plus that 1. That will give us 2k plus 3. And then don't forget, this is all over 6. So this right here is our target. That's what we need to get to. Okay? All right, so here's how we prove that. We're going to take our sequence, 1 squared plus 2 squared plus 3 squared and so on. Replace this n with k, so that's your original sequence. Now we need to add the very next term. So that's going to be k plus 1 squared. So again, make sure it works for the very first term and then the next term. All right, now remember, this was the original sequence. We added the next term to this. So this part in the blue parentheses is your s sub k. All right, so I'm just going to bring this down. We don't need to clean it up. Okay, now remember, all of this needs to somehow end up to be our target. That's our goal. Okay, so let me slide this up so we get some room here. All right, so the S sub k was all this. So that's going to be k times k plus 1 times 2k plus 1 all over 6. Okay, so that's the S sub k. Now I'm going to bring this down, but because of this 6 in the denominator, we're going to eventually need a common denominator. So I'm going to do that. So we're going to multiply the top and bottom by the same number to maintain that balance. Okay? All right, so this is a very tricky problem. Now, because of that 6 down below, that's our common denominator. Okay, so we're going to have k times k plus 1 times 2k plus 1 plus 6 times k plus 1 squared. Okay? All right, so again, all of this needs to somehow get to our target. Now this is a tricky step, what I'm about to do. A little hard to see, but this plus sign separates it into two terms. They have a common factor of k plus 1. So I'm going to factor out the k plus 1. All right, so that's going to leave from this term the k and the 2k plus 1. And then if I take 1k plus 1 out of here, we have that 6 times a k plus 1. That's a very tricky step. Okay, but look at our target. See this k plus 1? See the 6? We already have that aspect. So that means this part inside should end up being the k plus 2 and the 2k plus 3. Let's see if we can get there. All right, so if I distribute this k, that gives us 2k squared plus k. Distribute this 6, 6k plus 6. Okay, gonna have to slide up. You could always refer back to your target. I'll get there in a second. I'm running out of room here. All right, so if we clean up inside here, that gives us 2k squared plus 7k plus 6. Okay, and again, if I slide back up here, you can still see our target. That's what we're trying to get to. And we're almost there, because if we factor this, and that's why use your target to help you out. That's what we're trying to get. So this is really going to help us out. All right, so one last step. To factor that trinomial, you end up with k plus 2, 2k plus 3. There is your target. I don't think I'll be able to fit it all on here, but there you have it. There's your target. That's what we ended up with. There is your proof. Okay, so let me go kind of back and review this one here real quick. All right, so again, math induction, very tough concept. You have to show that it works for the very first term, step 1. Step 2, you have to show that it works for the next term. Okay? All right, so to end our lesson, I'm going to have a question of the day. I am an odd number. Take away a letter and I become even. What number am I? So you can email me the answer if you think you know it. This one isn't too bad. Even my wife figured it out, so it can't be that bad. Don't tell my wife I said that, please. And go Cougars. Take care.